When we build something, we often think about the benefits the economy will boost, the power will generate, progress will claim. But what if, in doing so, we cut off the very lifelines of our ecosystems? And what if the path to repairing that damage wasn't just possible, but already underway? Hey, everybody, I'm Stephen Shower, and welcome back to Stories Sustain Us, the podcast where we explore the transformative power of human stories to create a more sustainable world. Today's episode is all about restoration, resilience, and the surprising ways nature rebounds when we give it a chance. My guest, Jeremy Dietrich, is someone who's seen this transformation firsthand. From fieldwork in the Hudson River Valley to leading dam removal projects across New York State, Jeremy's career is a powerful example of what happens when science, community, and a deep respect for nature come together. We'll explore how his early childhood spent in nature shaped his path as an ecologist, why aquatic ecosystems are key indicators of environmental health, and how collaboration with hydropower companies, local nonprofits, and everyday people can lead to healthier rivers, cleaner water, and stronger biodiversity. We'll also take a look back at how dams, originally built for economic reasons like ice production, are now being reconsidered in light of their long-term ecological impacts. And you'll hear why understanding things like sediment transport and aquatic macroinvertebrates can actually lead to big changes for the health of our planet. Yes, we'll be talking about those tiny little bugs in streams and why they are really a big deal. Here's a bit more about Jeremy before we jump into this episode. Jeremy Dietrich is a principal aquatic ecologist with the New York State Water Resources Institute at Cornell University. His current work focuses on restoring stream connectivity through small dam removals and measuring their ecological benefits. With degrees from Cornell's Department of Natural Resources and the Environment and 2 decades of experience in ecological consulting and fisheries biology, Jeremy brings a rare mix of academic depth and hands-on insight. His work helps resource managers turn restoration goals into real-world action and helps communities reclaim their rivers for generations to come. So if you've ever wondered whether nature can truly bounce back or whether one person can make a difference in restoring what's been lost, this conversation is for you. So let's get into it here on Stories Sustain Us, where we are inspiring action through the power of storytelling. Good morning, Jeremy. How you doing?
Fine, Stephen. How are you?
I'm good. Thanks for being here with me this morning. Welcome to Stories Sustain Us. I usually start out by reminding everybody I'm in Seattle. It's a rainy, chilly, cold morning this Seattle morning. And you are in what part of the world today?
So I am in Ithaca, New York. It's equally rainy, although probably not as cold. Here at Cornell University. So,
Nice.
Which is where the Water Resource Institute is housed.
Perfect. Well, I know I want to jump into all the great work you're doing there at the Water Resource Institute, but first let's jump into your story. What's your story, Jeremy? Where did you grow up? What was life like for you? How did you end up becoming an aquatic ecologist? What's your adventure?
Well, yeah. So I grew up in Western New York, Western New York State, kind of the southern tier. Early on, I was always, like I suppose most kids, always wanting to go outside, playing, hiking, swimming. Definitely kind of like a formative foundation. My grandparents had a large country property, and it was very much like the over the river and through the woods,
Nice.
to grandmother's house. And so
Yeah.
Every weekend, or almost every week, we try to go down there, and they had a pond. And so that really kind of, like I say, kind of set the foundation for my desire to be outdoors, like my appreciation for the environment, for the biological communities, and how kind of piqued my interest of like how these like ecological communities are structured, and interrelationships, and all the observations that you have as a child, obviously not having the broader theory of mind to
Sure,
like
sure.
understand all the connections, but it's like it piques all those interests. So um yeah, so that really was kind of set the trajectory. And then during and so I hiked a lot and fished and that type of thing. And so going into through high school and as I was applying to colleges, um, being that I did a lot of fishing, I was like, I'm going to be a fisheries biologist, like
Yeah.
specifically, and so um, I applied to. Trying to think if I remember. I think I applied to like 5 schools: Cornell initially, Paul Smith's College, which is up in the Adirondacks, private school, Unity College in Maine, moonshot to like Alaska Fairbanks, and I think it's Syracuse at ESF. Um, and I got accepted to all of them, and I ended up I kind of narrowed down to like either Paul Smith or Cornell, just for a number of like practical and logistical reasons. Um, and but my mother did her work at Cornell, so
Okay.
um,
What was her background?
so
What was she working on?
so she did work with in the human ecology school, uh, like nutritional physiology, basically. So
Okay.
she um, her research focused on actually how like exercise and like nutrition influenced fitness outcomes, kind of at the two ends of the spectrum at like so for like how fitness and nutrition of like pregnant mothers influence like the early health of
Oh,
like
wow.
the child is developing, but then also on the aging end of the spectrum, how fitness and particular fitness but diet um influence the path of aging in like geriatric
Yeah, the
populations. So it's
geriatric
kind of
aging.
like
Yeah.
the two
Yeah.
ends.
She really did do the bookends. Yeah.
And
Yeah.
so so we had she went back to do some of her graduate work later, like when I was still in like middle school, early middle school. So we actually moved to Ithaca
Yeah.
for that in like the mid '90s, and so I ended up choosing Paul Smith initially because like having gone to high school locally, Lansing, going to Cornell didn't really feel like much of a difference. Like,
Yeah.
just like I'm still at home, so to speak. So,
Sure, sure.
um, so I decided to go to Paul Smith College, up in the Adirondacks region of New York State. And, um, again, kind of initially was, like a pretty, focused fisheries specific track. Um, but then one of the first classes I took there that first fall semester was like a stream ecology class. And, I was like casually aware, obviously of like stream processes, just being in the water and,
Sure, sure.
um, so, but that kind of really brought a greater attention to, the aquatic, invertebrates that are in the stream, the diversity, how they're, integral to a lot of the trophic and food web patterns in the aquatic and like even riparian environment. So,
Yeah.
um, so that, that kind of like pivoted slightly. I was like, oh, this is actually interesting. It's not totally unrelated to, to fisheries in a sense. Um, but I think there was like a bit of a mystique with the kind of like the aquatic entomology or extreme, ecology realm, and that, superficially, if you're just looking at a stream, you don't see all that biological diversity and that biological organization. You got to turn over rocks. You got to actually
right.
like actively investigate it. And so, that really fascinated me. The stream ecology professor, Paul Smith, Mike Recklin, I think it was. That was definitely it's like, okay, this is really what I want.
We can
Kind of focus on.
see that
And
connection
so,
between when you were a kid on your grandparents' home, kicking over the rocks in the pond and looking at, I'm sure, at least what I'm imagining is you as a child seeing those bugs and those, benthics and everything and being fascinated by those. And then, a couple decades later in undergrad, kind of rediscovering that interest that ties through your life there. At least that's what I'm imagining is happening in your story. So I can see those connections that you said early on kind of formed your foundation for wanting to be outside and work in fisheries or work around water. And here you are piqued by this ecology class. So that I can see those connections being made. So that's awesome. It's awesome.
So once I kind of through my first couple of years at Paul Smith and getting kind of some of the core kind of what do you call it, like what do they call not blanking the like your core baseline courses. I forget. Right now Paul Smith is a 4-year school, but it was a 2-year school. In the early 2000s. So like I only had 2 years there. So I decided to transfer to Cornell to finish my, so I received a full associate's degree at Paul Smith's AAS degree. And then, transferred to Cornell to finish my bachelor's degree.
Bachelor's, sure. That makes
sense.
And
then since I had a lot of my core math, grammar or whatever, types of ethics, basic ethics courses out of the way, I could focus, on the professional courses.
Yeah, so those upper division courses,
at
right?
Cornell.
Yeah,
and so then I kind of really was able to kind of delve more specifically into like the taxonomy, like aquatic entomology, and like water resources, hydraulics, stream ecology, a lot of the the kind of the more specific property based course, that really get you into like kind of like the theory and how are these systems structured, from a mechanistic perspective. Bobby Karski, who is a professor here, taught aquatic entomology and co-taught stream ecology. And so she was very much a mentor here.
Nice.
I towards the later years, undergrad, I TA'd, for the course, the stream ecology course, and that is, and so actually the stream ecology course was at the time co-taught with who was my undergrad advisor, Mark Bain, and when I finished, as I was finishing, towards the end of my undergrad, I ended up, there was a project that Mark was overseeing in the Lower Hudson Valley or Lower Hudson Estuary, in and around New York Harbor, looking at some of the ecological effects of the dredging efforts that were performed like after the September 11th attacks.
Wow.
In New York Harbor, to when initially when it was potentially recovery effort.
Yeah, of course.
They couldn't get the river around that area was shallow, like they couldn't get big barges and certain size boats up to the shoreline, which is what they needed. So they did a lot of emergency dredging, and my understanding of kind of the regulatory background was essentially that, given the nature of this, like, we need to do this now.
Yeah.
We know there are typical, environmental reviews, but
All that was
we
suspended,
need
and
to
you
get
just went.
survivors out, and
Yeah.
we can review. We'll do an environmental post
Yep.
dredging environmental study.
Right.
So Mark has a long history of working in the Hudson, and so in the Hudson river ecosystem.
Yeah.
So I was brought on with that to that kind of looked at both the benthic invertebrates in the estuary, and there's a fishery component as well. Like, so I co-captained an otter trawler research vessel. So that was a 2-year study.
Were you still an undergrad at that time, or was it just right after?
No, so I finished my undergrad.
Just
so
finished
this
undergrad. Yeah.
Like 4 or 5 months.
Yeah. Wow. That's a big
Post undergrad.
Yeah. First kind of big real world job, so to speak, after your bachelor's. That's a big.
That's kind of It's the out of the frying pan into the fire. Trying to captain a boat in New York Harbor, and
not to mention the
harrowing in and of itself.
The magnitude of why you were there, but and all of the emotions and everything that was going on in that time period, on top of just the significance of the environmental work that you were being tasked with. That is a big first big job.
Yeah.
Wow. Yeah.
So I was involved. Obviously, generally helping or assisting with the field efforts on the boat, and we'd go down for about a week. About a week a month, do the fisheries and the benthic sampling, go back to the lab here in Ithaca. I would do all the benthic identifications.
Yeah. And just for folks who may not be,
some of the other staff, that was my primary, to kind of like process each month's benthic invertebrate samples, and get that ID'd and enumerated before we went to the next month. And
can I ask you real quick, Jeremy, just for the listener who may not be familiar with that term, the benthic invertebrates, just explain in kind of layman's average person, what exactly does that mean? Just so people can understand the story that you're telling. I know what it is, but I'd rather hear what your description is for the average person when you say benthic invertebrates. What are you talking about exactly?
Yeah, sure. So if you in your mind, you take kind of like a cross section of the aquatic environment, you have surface organisms that kind of live in the water column, those are called pelagic. You have near shore organisms that you might hear the term littoral. But then organisms that live within the bottom sediments, or essentially sit on the bottom. That region is called those. So they're referred to as benthic organisms. So most you think of like crustaceans, snails, gastropods, mollusks. A lot of worms are going to be in the sediment. In the case of freshwater, the aquatic insect larvae are in among the rocks. Flowing systems and marine systems. There's lots of crevices and whatnot, on the bottom and the substrate that organisms use for refuge and such. So that's when we refer to benthic invertebrates, that's generally what we're referring to. Sometimes you might hear like benthic fisheries. That would be like flounder. Sometimes they're called like brown fish, so like sea bass or rockfish type of fish that associated with the near bottom.
With the near bottom, sure, yeah. Perfect. Thanks for helping folks understand what you were talking about, so they can follow the story. So,
Sorry.
sorry for the
Yeah.
little sidebar there, but
Oh, yeah.
I
Yeah.
thought it
Yeah.
was important. So yeah, so you're doing this research on the Hudson after 9/11, and you're going out collecting samples and then going back to the lab to categorize what you're finding. And that sounds like that was happening kind of on a monthly basis.
Yes.
Is that
Yep.
yeah?
So, yeah, so we did that it was a 2-year project.
Well, yeah,
Uh, and then, and so we were, uh, basically trying to assess like the rate of recovery of, because with the dredging effort, effectively you strip the bottom
yeah. You
clean.
scrape it all clean,
And
right?
so, uh, and so we had, I think it was like 4 or 5 sites kind of within the dredging area, and then 4 or 5 sites further upriver that were not dredged. So we almost had this, compare, what should the bed the community look like, and how soon over time will it begin to recover, and
Sure.
um, so and there's a little bit of, I mean, we did find that within 2 years there was a great deal of recovery. Some of the deeper sites shifted, like, because now they're deeper, so they kind of alter the fish communities a little bit. But
Yeah, a little.
but
Yeah,
that
it's a different
overall,
habitat
like,
now.
the rate of colonization of these organisms, in the estuary with the tides. I mean, things get can colonize the new surfaces pretty quickly, and so um, the the broader kind of conclusion was that basically just let it let it alone, so to speak. Let nature recover itself, and
Yeah,
you'll uh, return to a similar state that that we didn't see any, like, I'd say, like, long term, like, chronic issues from that.
yeah,
Again, as long as you don't disturb any further, so to
yeah.
speak.
Didn't create like a,
Um,
for lack of a better term, but like a desert kind of
right.
situation where
Yeah.
organisms didn't return to one patch, or everything kind of, as you were saying, nature kind of has this tendency to restore itself if we give it the opportunity to do so.
Yeah. And so then I did that. I worked also as a part-time, also with a private consulting company, Ecological Associates. That was more, I've got a free weekend here and there, or here's this project we need we need somebody, we need another person. So I uh, so I was also, had that work kind of in tandem with, like, full-time, like, Cornell scientist,
Yeah,
research aid, uh,
yeah,
staff. And it was an interesting perspective because um, much of the Cornell work is theory and academic based, and you're asking, like, broader research questions and trying to um, identify, like, ecological mechanisms, or how to explain what processes that you're observing. Whereas the the consulting work, we did a lot of work involved with, like, hydropower licensing
mm,
efforts. So Federal Energy Regulatory Commission relicensing settlement work.
sure.
Um, so uh, part of that, is assessing the fisheries and kind of ecological conditions around hydropower, small hydro, in our case, small hydropower operations, kind of within New York and kind of New England. I was in Massachusetts and Connecticut on a couple sites, and I think northern Pennsylvania. So, and that was, it was a more pragmatic, I'd say, like, pragmatic approach of, like, how how can you adapt, operations to conform with, a given like regulatory
Yeah.
environment,
Yeah.
or all the time. And so, whereas, again, Cornell was very kind of like theory based. This was like kind of a pragmatic, like on the ground, like this is what we have to work with. How can we, here's our, we found, I mean, it's kind of a hypothetical example, but like, we found this particular species of concern, like it has passage requirements. How can we, manipulate the spillway design that we can conform to,
Right.
so these organisms can say move from upstream downstream safely without like going over a spillway and like
Right.
smashing into a rock.
Yeah.
So,
I appreciate you
you didn't have
explaining
as
that.
much of the. Oh, yeah, go ahead.
Yeah, just because I think regulatory, staff who work on regulatory issues, I sometimes get get a bad rap that you're just out in the field trying to do gotchas and trying to, catch people, not following the regulatory requirements so that they can be punished. But, what you
Mhm.
described was, was working with these, small power plant companies and I'm sure co-ops and other things that are trying to create power for people that we all need. So
Mhm.
you're not out there trying to, do a gotcha. You're out there to try to work with them to make sure that they're designing things and trying to meet the regulatory requirements so that the environment can be healthy and the power generation that is required can be met. So I really appreciate you kind of taking time to explain that, because I think regulatory aspects of environmental protection often get a bad rap, and folks like you are out there just trying to help, trying to make all the parties kind of come together to do what's best for all the parties. So thank you for explaining that, because
Yeah,
I think that's often
another
misunderstood.
little maybe anecdote. Sorry,
Yeah,
anecdote on that too is like,
please.
as you mentioned, like the kind of maybe the bird's eye view of that is, it's like, it's all commercial, and of course, like the certainly the corporate CEOs are in their high rise office somewhere or whatever.
Sure.
But what I think it's worth recognizing is a lot of the people that the local individuals of like a lot of these, in this case, like hydropower operations, the employees of that, you know, um, location. I mean, they live locally. They want to
Yeah.
catch
Yeah.
walleye as much as the next person, and so it's like,
Right. They want to do it
if we
right
can do
also.
something that's, it's not onerous, but it's kind of an optimal way to,
Yeah.
allow the, environmental functioning, but so and maintain these kind of a balance to the ecology. So that's
Yeah. Great point.
like you say, they're not all you know whatever, bad people, so to speak.
Right,
So
on all sides, everybody's trying
yeah,
to do the right things. So yeah, thanks for pointing out too that the folks you were working with were wanting to do it as best as possible. Also, it's so yeah, it's regulations often just from my experience often get a bad rap, and sometimes deserved. Sometimes they do get in the way, and sometimes they get outdated and they need to be
yeah,
updated or removed from the books, and that's a really hard thing to do in government. Once something is on the books, it's hard to get it off the books, so to speak. But in general, folks like you and the people you're working with are trying to abide by the law that somebody else created, but also trying to do what's best for all interested parties. So I think that sometimes just that's a part of this story that goes untold sometimes. So I appreciate you bringing that up.
yeah, because another thing too, just from the perspective is most of the FERC licenses, I think like 30 to 50-year license spans, and so like you think of you know these uh, operations. Yeah, last time they were licensed was like in the 60s and 70s and early 80s,
Right,
right? And so that environmental regulatory environment was very different than it is in 2010.
right.
So it's like, okay, it's like a different world, so to speak. You've got to comply. How can we optimize the
Yeah,
system
how can we
to,
do it as
like, you
best we
guys
can?
can generate power in a meaningful way and
Yeah,
reasonably economically, and you know you can allow the, um, the local, the fish communities or the, other, um, organisms of concern to try to survive. So,
Yeah, yeah. So that work, it seemed like, laid a pretty good um, foundation then for you for the for the work you're kind of doing now with the state of New York's Water Resource Institute. You were doing all this work earlier in your career, looking at how to, because hydropower is often used dams. So
yep.
you're involved with dam work earlier in your career for regulatory perspectives. How do these operations meet the federal regulatory environmental commission? What they're told to do. And now, jumping ahead a little bit in your career, what you're doing now with the Water Resource Institute is you're looking at outdated dams and outdated culverts and things that may not be needed any longer from a
Mhm.
human perspective. Why they were put in 50, 60, 100, 150 years ago, or whatever they may be. You're looking at how to remove those. Is that kind of that connection from your career path from working around dams to now trying to figure out how to remove dams? Did I make too big of a leap there, or is that a connection that I'm seeing?
Yeah, it definitely was like something that I kind of initially latched on to. Uh, yeah, so my work, uh, being involved with this kind of barrier mitigation slash dam removal project, with WRI started in 2016. I was uh, a staff. I was a research associate in the Department of Natural Resources, which is just a separate department than biological and environmental engineering, which is where WRI is housed. Um, I I just finished my master's degree, so I went back, to get my master's after a few years of working, both at, just strictly working.
Yeah.
And um, basically my master's degree was looking at how aquatic macroinvertebrate communities respond to invasive species in like wetland environments, which is probably another 40-minute topic, but um, the but the connection kind of is that, as in Furno Hall, our kind of natural resources building, and I had at the time a postdoc kind of cross paths in the hall, and it's like, oh, we've got this emerging um, project that I'm kind of looking at taking on, and there's a component of it that we're going to be doing like aquatic macroinvertebrate samples, like in these streams around some of these potential sites for dam removal. So me and my technician don't we don't have a background in aquatic entomology or taxonomy,
Yeah.
and so they were like, oh, but like you could probably like ID these or site ID these like so much faster than we would need to like learn it essentially.
Yeah.
So I uh they're like, well, we'll go out, we'll collect, we'll bring everything back to um Ithaca, and then you can do the IDs a couple times a year basically. So getting just wrapping up my master's, like I was like, I think continuing, we're contemplating like doing like continuing like PhD work with
Oh,
it.
yeah. Yeah.
So in my mind, I remember saying like, oh, I was debating. I was like, well, I definitely don't want to manage a whole thing at this point, but I could see like, if you're bringing, a handful of samples back, a couple times a year, like, I could make that work.
Sure.
So, the first early summer 2016, there were like 4 or 5 sites in the Hudson Valley region that is kind of like the pilot-esque area for this barrier mitigation effort funded by the Hudson River Estuary Program within the New York State Department of Environmental Conservation. And so the initial couple of days going out, I was like, I'll go out with them to the sites. That way I know make sure they're doing the correct methodology when they're collecting, so everything's standardized, so that doing an appropriate habitat assessment. So if I see some differences, I can okay, this is why we might be seeing these, as opposed to just a broad methodological error.
Sure.
So I went out, helped collect, got to see the sites, and a month or two later, the postdoc ended up taking a faculty position, and basically, and leaving for that. And the principals at the time, my supervisor, Pat Sullivan, he's a professor emeritus now in the department, and the principals in DC, and then at WRI were like, what are we going to do with this? I don't know. Everybody's looking around. Okay, just give it to Jeremy. Okay, that sounds good. So I ended up
so you're part-time, occasionally helping
eventually I was
here,
this
there.
Is exactly what I didn't want to do.
Yeah, kind of got sucked into taking control of it.
But the caveat and why I didn't just kind of hard stop was, as we kind of segued into this, is I have been on the private consulting side, been involved with ecological sampling around hydropower establishments, right, and seeing how they create different habitats, and how can you it's like a game of mitigation as far as effects, and because obviously most of these hydropower establishments are obviously going away, so the prospect of having obviously smaller kind of mill dam size systems, but still you have this static, this dam that's been in place for potentially hundreds of years. You have this static system, and because even doing the hydropower work, you're like, I wonder what would happen if we just took the dam out, just kind of hypothetically, right? And so this was an opportunity to be like, oh, we can actually see what would happen if we take the dam.
Yeah.
So that really, really was of great interest to me, kind of both intellectually, this is a cool real world, real time, long-term experiment.
Yeah.
And but also recognizing kind of this, we've had these broad human anthropogenic impacts on the landscape just as a human population for, obviously long time, thousands of years.
Yeah.
And it's it kind of captured the essence of recovery, of the resilience of nature, right? So you can beat something down for 200 years, and then take the dam out, and 3 days later you have
see what happens. Yeah, kind of connects to your.
It's almost, I don't want to say incomprehensible, but you're just illustrating that type of natural resilience. Is encouraging. It's hope isn't all lost. Absolutely. So much of the broader narrative about pollution and climate change and microplastics. Well, you're just kind of inundated with the
bad news.
Doom.
Yeah.
Which, not to minimize those concerns, but it's here's kind of a broader case study of things can get better if we implement the right strategies.
Absolutely.
And so yeah, and yeah, and so then I started to, the first year, kind of established 5 sites, in the Hudson Valley, and then of New York, and
Now these old mill dams you'd mentioned
yeah,
that,
so these
yeah.
are
So
all old.
five. So what, when you're talking about a mill dam, is that, kind of something that's 5 feet, 7 feet, 10 feet, 2 feet? What kind of barriers are you talking about at these 5 sites to help people understand the size of the dam that are is being removed in these projects?
Yeah, so they vary, generally like a small dam kind of categorically is, you know, usually less than, I think, 20 or 25 feet.
Okay.
I mean, from a regulatory perspective,
Yeah.
most of what we're dealing with are, um, 5 to 12, 15. In some cases, you can see where, like, maybe the original dam or fieldstone or pour was, 5 or 6 feet, probably in like the early 1800s, then that filled up and then they built
Yeah,
another
yeah.
five
The
feet and
sediment
another
can't.
5 feet.
Yeah, yeah.
Um, as things filled in. So there's a couple dams we have that are, they're, in that 20 to 25
Sure,
foot,
makes sense.
but generally, um, 8 to 12 feet on average. And, that, and, most were like old kind of, original water power mills, sawmills, grindstone mills. Some were early like water supply, smaller hamlet-esque water supply reservoirs.
Yeah.
Um, one was actually, uh, it's interesting to think about today. It was for ice production.
Sure.
So,
Yeah, it is interesting for
late
to talk about today.
before refrigeration, the late 1800s, like ice was a commodity.
Yeah, yeah,
And, if you lived on a lake, obviously you'd have like an economic, a level of economic activity in the winter that you could like saw your blocks of ice out of the lake. But like,
yeah,
if if you just had a stream, if you didn't have that laminar frozen surface in the winter, it's like, oh well, we can get into the ice market if we dam the stream and create our own little
yeah.
small pond, but it would still be, so one of the sites was built specifically for, um, Brown's Pond Dam and, on the Otter Kill, and so I think it's in Orange County, New York, and so that was for ice production. They had a rail spur that came up, and you could like saw
Yeah.
the winter saw the blocks of ice put on the rail car, send it to
Send
New
it to
York City.
the big city. Yeah.
Um,
It's interesting how these pieces of history come together too. Talking about what life was, what how we were changing the landscape 200 years ago to our benefit, and now you're looking at how can we undo that. So I love those
yeah,
connections. Yeah,
so
it's
so a
fascinating.
lot of these were put in. They had legitimate economic
Absolutely. Yeah.
drivers and incentives at the time. That
Yeah,
was
and
obviously the broader like that kind of you know early U.S. kind of colonial early U.S. era. Um, you know resources were thought to be unlimited, right?
yeah,
So,
well, even up into the 20th
it's like,
century,
oh
not too
yeah,
long
we
ago,
we
right?
put this dam up, like,
Right.
the shad can't get by, but they can get by over on this stream, or
Yeah.
so, and then they, obviously that suite of homespun cottage industry, became obsolete, and but obviously the dams remained, um, and again, the the prior levels of abundance, people didn't notice like the trickling of decline, right?
Right, right.
Of all sorts of, especially migratory species. And now we're obviously, in the last 30, 50 years recognizing, oh, the effects of eels and shad and herring. And so,
So what are some
um,
of the lessons that you've learned here with these 5 sites with the removal of these structure and as you're talking now about how we understand differently these environmental patterns and these ecosystem patterns that 200 years ago wasn't that they were purposefully trying to hurt these systems. They just didn't have the knowledge or didn't think too much about it or thought that it would be fine. So now we know better, and we're thinking differently about how we can live in closer unity with our ecosystems that we share with other critters and creatures. So you've gone through these 5 sites, and fingers crossed, nature can heal itself. What are you learning from how quickly can nature rebound as you remove some of these structures?
yeah, so it's encouraging. So I will note, so that those we had originally five sites, like in 2016.
Yeah,
Yeah, we've since added. I think we're up to 12 or 13 now that we've
great.
collected monitoring data within the Hudson Valley.
Yeah.
Between Peekskill and Albany, and in the last couple of years we've moved to include sites uh, uh, in collaboration with like the Great Lakes or Great Lakes partnerships. Doing similar work in the Lake Ontario watershed now as well. So I've got a couple sites in the Little Salmon River Basin north of Syracuse. We did one site on Oatka Creek, which is in the Genesee River Basin south of Rochester. So, um, and so what we see is, um, with multiple use. So the kind of the broader monitoring strategies to collect, a few years of pre-removal data,
Yeah.
upstream, downstream. So, in these systems, um, they were historically, a free-flowing stream. You put in a dam, you create, an upstream impoundment.
Yep.
That fundamentally changes the environment upstream. Downstream, it's still largely a flowing system. And so, you create this, natural disconnect in the system, but you also create this like habitat disparity,
Mm-hmm.
in a very, obviously very short distance, just over the dam, but, over the course of, 100 meters, you have like a stream community and then what's now like a ponded community. And, again, over many decades, these ponds, because you're interrupting like the natural sediment transport, from the watershed that's taking, erosive material largely from the headwaters and would normally transit it through the stream network,
The whole system,
to
sure.
the delta or the mouth.
Right.
Now
Right.
that's being interrupted, and a lot of that's being captured,
Right.
and deposited in the impoundment. So that's going to fill up. Um, Obviously, over time, you're going to have weed growth come in. As the water gets shallower. Obviously, you cut down all the trees around where the impoundment now is, so you get a lot more um, sunlight and
Direct
solar
sunlight.
loading into these systems. So,
Yeah.
um, you increase the water temperature, you often decrease, dissolved oxygen, and so you have these fundamentally different sets of systems, and that, again, over time, like degrades the water quality upstream. And so, you create this, well, because, you've disconnected, like, again, a lot of the natural hydraulic and sediment transport, nutrient transport processes that, is, the organisms, stream organisms have like co-evolved with. You kind of get this, what we've seen over all of our pre-removal, sites, like multiple years of pre-removal data is, you get this uh, kind of status of like what I'm calling like arrested impairment.
Mm-hmm.
So, um, often we see, the benthic communities, macroinvertebrate communities and upstream, are much less diverse, much less biodiverse. You often now have, poor benthic habitats. Almost everything's kind of like silted in. If anybody, you walk upstream in a silty, impoundment, you like lose your boot, the first step into the mud.
Yeah.
So, and so like, you'll have often, um, anywhere from a third or less of, the biodiversity,
The diversity,
macroinvertebrate
sure. It
biodiversity
is kind of,
upstream than you do downstream. And so, and of course the in-stream habitat is like all silt, and there's nothing to push the silt out because the dam's blocking
right.
it. So like your
Right.
habitat's consistently degraded, benthic habitat. So, you get this like arrested impairment, and like, now we've got some of our original cohort sites from 2016 that I went back to 2023. It's like these ecological metrics that we use, like certain habitat, percent gravel, or proportion of mayflies, or species richness, or like this biological assessment profile score, which is like a one-off water quality score that the state uses, New York State uses, to DC uses to, kind of assign water quality parameters to sites. They're all very, impaired or low water quality score upstream, even though the downstream might be classified as like only like slightly impacted, or in some cases like non-impacted. So,
right.
And you just see that, that status is like kind of, like I say, just consistent.
Yeah.
Because you've eliminated like the natural mechanism that would be
That
used to
natural connectivity and flow and everything, right?
that would be, they'd be able to correct it.
Right.
So, and so, you're like, okay, if we have, a barrier in place on these streams, and you want to improve, local, water quality, or the aquatic connectivity, or like ecological robustness of a reach, you're not going to achieve that with the barrier in place.
Right.
You need to restore like the natural processes that keep streams kind of like this perpetually dynamic system. I mean, we've all, especially after big floods, which, I mean, floods do a lot of damage, obviously, but they're also important, for the stream
part of the process, right?
processes. So like, we've, I don't know, people that fish will, it's like, oh, I came back and there used to be a hole here. Now there's not, it's filled in, but now it's downstream, right? So,
right.
So one site that actually I just wrote up a case study manuscript paper that'll be out in Ecosphere later this year, I think. It's been accepted. I'm just finalizing the some of the documents to the publisher.
Yeah.
So we have one site on the East Branch Wappingers Creek in Dutchess County, New York. The site was like Shap Pond. I think it was a old water supply, for the local hamlet there. And so that was the first of our original cohort of sites. That was the first dam to come out.
Yeah.
So we have, a year of pre-removal data, and then it came out. That was in 2016. It came out in 2017, or late 2016. So 2017 was our first post-removal year.
Yeah. Data collection.
Of data collection and monitoring.
Yeah.
And then we did our monitoring for 3 consecutive, 2017, 2018, 2019 afterwards. And, we looked at the aquatic invertebrate community. I did like an in-stream, like substrate in-stream habitat assessment. And the other component is kind of like a cross-sectional channel morphology survey. So we kind of take the elevation points across the channel so we can draw like a profile. And so, if you look at collectively that data across time, you see that, after the first year, 2017, you see a lot of the substrate that's behind the dam are clays and silts and sands, or relatively fine sediments, and fairly mobile from like a hydraulic standpoint. It doesn't take a lot of erosive force to move those
to move them downstream. Sure.
So, so once the dam came out, you see a lot of those sediments emigrate,
start moving down. Yeah, sure.
Downstream, some they start to fill in like the old plunge pool below the dam, and then downstream of the dam, you tend to have coarser. After many years, you have like a coarser set of substrates, like boulders and large boulders and cobbles,
sure,
because
it's not getting that small sediment.
Kind of the opposite,
right?
Like mechanisms. Downstream of the dam, you have a lot of those gravels and sands get eroded away just through the natural processes,
right?
But then they're not being replaced from upstream sources
with the smaller sediment, right?
The upstream sources are being blocked by the dam,
right?
And so downstream of a dam, you get like just increasingly coarser, big boulders, and so, but once you kind of had all those spaces amongst the larger particles now getting kind of filled in with all the stuff that was upstream. And then, so it took, most of that was flushed out in a year. And then you just had kind of an incremental, as you get high water events or, just pulses, some of the, pulses more of that stored sediment downstream. Then you also start to repopulate with upstream sources of gravels and smaller cobbles that are getting washed in and repopulating that.
Yeah, starting that
channel reach. So you start to normalize your broader habitat, your broader
sediment transport processes are starting to balance out.
Yeah, so those start to normalize. The upstream channel starts to erode back to what was the natural channel elevation.
Right.
So, and what we found at Shep Pond is that, after 3 years, by 2019, if you ran statistics against the various macroinvertebrate population or ecological biometrics, that, there's no significant difference, upstream or downstream, for a lot of those metrics. So
they all just kind of,
and so like if you were to just, show up in 2019 or 2020, it actually went back for 7 years in 2022, or 2023, with the exception of kind of like the old dam walls that were just kind of, like the far, abutment walls that were built into the hillside.
Right.
But other than that, like if you just looked at the stream, like you wouldn't even know there was a dam there for 80 years or whatever.
Yeah, fantastic.
So and in the you'll see in the PowerPoint I sent you, like this the kind of the case study section, but there's I've got 2 pictures, one from like a month or 2 after the dam came out in 2016, and then one in like 2023 in the same reach. And like I say, you wouldn't except for the relic of the what's left of the dam. Like you could walk right by and not even know there was anything there.
Yeah.
So and so that's, I think, the yeah, again, as I kind of initially mentioned getting into this, like that's kind of like, I don't know, like the resilience and the hope that of like, oh, things aren't all lost. It's like, that's yeah, it's a pretty powerful kind of statement, kind of from nature, of just like, you can take this out and you can restore the system, even in 2024, with all the other things that are gloom and doom broadly.
Right.
But it's like, no, nature's very resilient, and there are opportunities to restore ecosystems and aquatic environments and improve aquatic connectivity, and you'll have a meaningful impact.
Yeah. Well, I
Doing
love
so.
that message. That in that's one of the reasons for this that I started this show, is because there is so much doom and gloom out there, and there's a lot of doom and gloom. There's a lot of things that are not going the right direction, and it's not to ignore those things or minimize or downplay those things, but it's stories like yours and the work that you're doing there in New York that also need to be told and also need to be heard. That, as you pointed out, nature is resilient. If we work with it as opposed to against it, we can help nature restore itself pretty quickly, and in a matter of 3 years or 7 years. I mean, these are pretty quick rebounds, and your story is not just unique to some of the rivers of New York. I mean, there's this is
Right.
happening in other places around the world, and with similar results. We're seeing that nature will return itself. And then humans, we have a role in helping that. I mean, we had a role
Mm-hmm.
in hurting it, degrading it, and we have a role to play that can help restore it. And the speed at which nature can restore itself, if we work with it as opposed to against it, is through stories like yours demonstrating pretty quick. It can happen pretty quickly. So, like you said, I share that optimism and that hope that if we collectively can start doing some of these things as you're demonstrating can be done, we can turn this ship around, so to speak. It doesn't have to be all of the doom and gloom stories that we hear. So I'll share on our website the link you provided me, to some of the study results, so folks can kind of do a deep dive and see some of this information firsthand. And I'll use some of the images that you shared as well in that PowerPoint to help demonstrate. And um, I can probably post that on the show notes as well, so people can see the presentation also. But really, thank you, Jeremy, for what you're doing and demonstrating the speed and thoroughness of how nature can restore itself if we work with it. So, I want to give you a moment. What's your call to action? Now that we're kind of into this story, and people have heard your story of these dam removals and the benefits that they can have, and we could continue talking for another couple hours about the benefits. There's way more than what we covered undoubtedly today about water quality benefits and other aspects of the work that you're doing. But in the interest of time, um, want to move on to your call to action. Want to give you an opportunity to ask people to go do something to make a difference, make the world a better place. So what is it that you want folks to take away from your story today, and then go turn into action into their own life?
Yeah. So, there's a number of ways that folks are interested in supporting, like, aquatic connectivity and restoring some of these systems. Um, you know, I think, of course, the first kind of generally is, like, inform yourself of what stream restoration projects are occurring in where you live or in your local community. Um, that can be affected, or they can be implemented by obviously state departments or state agencies. Again, here at WRI, we work with the New York State Department of Environmental Conservation. A lot of the money that we get from, or that supports these efforts are from like our Environmental Protection Fund. Also, we collaborate with a number of local nonprofit groups. We're in contact with like some of the folks with Riverkeeper and American Rivers that
Sure.
help identify
Great organizations.
Both, kind of we'll call candidate dam removal sites. Often local nonprofits can work with, potential willing, owners. Often dams are usually can be like municipally owned or privately owned. Sometimes it's the nonprofits can have a different kind of I'll say approach value than maybe a state agency in trying to engage with certain stakeholders about dam removals. And often nonprofits rely on volunteer efforts. So if you hear of through a local nonprofit about their efforts for dam removal and aquatic connectivity, see if there's volunteer efforts. I mean, of course, there's always like sponsorship requests and such. You can help financially with a project through a nonprofit. And there's a lot of work that goes into these removals. I mean, you don't just like blow them up, right? So,
right.
There's we obviously do like kind of a formal monitoring protocol, but often increasingly there's like citizen science type opportunities that people can help with collecting data. Once the dam comes out, that there's a lot of exposed shoreline now that was formerly inundated. You can help with like riparian restoration, like
sure.
tree planting. There's been a lot of that press with respect to the big Klamath Dam.
Yeah, out here in the Pacific Northwest. Yeah.
Removal efforts there on the West Coast with replanting these vast now kind of defective floodplains and minimizing the soil erosion around. The local soil erosion with those drawdown efforts. So that's something you could do actively in your local area. Another thing that's worth acknowledging is the bipartisan infrastructure bill, the federal bill that was passed. It was last year, 2 years ago, the Infrastructure Investment and Jobs Act that appropriated over $50 billion to broader water infrastructure projects, but included around $800 million for dam removals. Removing outdated, hazardous type dams. I mean, there's a lot of chatter and stuff with local, the way the cost cutting measures are now with the federal government. So
sure,
you can as a voter, voice your support for that type of funding, to be retained or continued to assist with the the physical removals of a lot of these dams I'd say those are the three big
perfect
kind of pillars of broader support for aquatic connectivity.
Wonderful. Well, I'd echo all that. I couldn't agree more with those directions to folks. I hope folks are listening and take those to heart and take action on that as well. So now, Jeremy, want to transition into kind of the last bit of the show. Every episode, I ask all my guests the same 3 questions, and we talk about hope. We end the show on what I like to think of as an upbeat note. Sometimes our discussions are around hard subjects, right? And in this episode, talking about some of the choices us humans made, a while back. So we're trying to correct those and restore the environments, and there's challenges still ahead of us. So so I want to end on thinking hopeful thoughts for the future. So I want to ask you 3 questions about your hopes for the future, and hope kind of being defined as a mental state of mind, not an emotion, but you can have a vision for a better future. You can have some plan of action or steps to take to implement that that vision of a better future. And you have a sense of agency that there's something you can do about it. You might not be able to do it by yourself. Most of the time we can't. We got to bring other people along on our vision, and on our the actions we need to take. Well, you have a vision, there's some steps, and you have some agency to make a difference. So 3 questions coming up. Don't think too hard about the answer. I'd love to get kind of people's first kind of heartfelt response to these questions. So the first question for you, Jeremy, is what's your vision for a better future? And it can be for you personally or professionally or for the world. What's your vision for a better future?
Better future. I think that take I think one is be informed of kind of an awareness around you of kind of environmentally and how your individual actions help contribute to outcomes, I guess, one way or the other, right? And I know that's kind of a cliche thing, but so some things that I do, for instance, it seems trivial, but like for instance, so I have like a compost right bin, and as opposed to just throwing all the foodstuffs in the trash, and so
Sure.
and I have a backyard where I can do that, but cumulatively, it's like, okay, if like there's a surprising amount of weight of like foodstuffs that you throw away every day or weekly, and so collectively that's less going into like a mainstream waste
makes a
stream, and like
difference.
the weight of that and kind of from like a carbon balance perspective of transporting that waste to the system.
Yeah.
So that's like a small thing that kind of and and I'm optimistic that there's a broader there is a broader public awareness of like the value of open spaces and environmental you know resilience. There's from like say like maintaining say public lands where we can go recreate to um just trying to be involved like in some of the local volunteer for some kind of local cleanups and just things like that again might seem in their own thing somewhat trivial, but if you build an economy scale around it, you can make some meaningful improvements and changes. So
all adds up. So let me ask you the second question then. So your vision for a better future is for folks to be better informed and about how their place in their environment and make better choices, even if they think it's a small choice, because these all add up to make a difference. So, and I think you kind of answered this second question already a little bit, but to give you an opportunity to expand on that a little bit, why is that important to you that people are informed and are making these better choices? Why is that important? Why should anybody care about that?
I mean, I think being informed, you can and keeping yourself educated on the the issues that that are important to individuals. I think just being informed allows you to make a rational decision. And again, kind of in this kind of almost hyper like social media-esque like clickbait environment, like people are throwing all sorts of chatter at you, right? And it's sometimes the noise is, so to speak, can be overwhelming. But I think
absolutely,
being recognizing like what attributes are important to you, and knowing how they interrelate with what your goals and objectives are. Again, just I think it allows you to be I phrase it, a rational stakeholder in the issues that are important to you. So you may have you may disagree with other people about how you want like maybe a certain management outcome or environmental outcome, but but at least being informed and be able to articulate your rationale, somebody else can articulate their rationale, and then it's a discussion as opposed to just like an argument per se.
Right.
And it's like, okay, I see where you're coming from. Here's my point, and generally that's how you can achieve compromise, right?
Yeah,
so like
find some
I kind of
common
go back
ground.
to the the work with kind of on the private consulting side, but even within like some of the scam removal work. I mean, it's you have individuals that are like, oh, I live up here, I like the dam, and oh, you're taking it away. I mean, to a certain degree, like everybody's changeovers, right? But to there's one example where I interacted with a local resident, and it's like, oh, they're thinking of taking the dam out. Like, I don't know what the problem is. Like, I walk by and it's like, I see fish, I see plants. It's like, it looks fine to me. What's the problem, right? And so, but then it's like, well, sure, but the plants are this invasive species. The fish are planted. They weren't native here. They don't belong here. It may look like a big pond, but there's like 6 things growing, invertebrates in there as opposed to 30. So, and so you still may want a pond for the sake of a pond. Like I like a pond. I want to fish for bass. I mean, that's totally rational, but like, at least now you're informing. Okay, here's my trade-offs that, I can accept them, or I can say like, okay, I can see this perspective. Maybe there's is there a middle ground, or okay, if I take the dam out, I can fish for shad instead of bass. I don't know, is that something I want? But at least you can make that you provide the capacity to allow people to make
better choices,
those decisions amongst themselves, and then they don't feel railroaded into a particular opinion because they don't have a choice. So I think that having that dialogue and ensuring people know what the the information is one way or the other is never bad.
Perfect. All right, so last question then. Imagine the future you just described, and for the reasons you described it, that we're living in this future, and it's happening now. People are better informed now. There are these conversations, even disagreements, but conversations that are intended to provide people accurate information from all different perspectives are happening, and people are informed and making better choices and finding common ground with each other about their place in the environment and the choices we're making of how we interact with that environment. All of that you described in the future is happening today, right now. How does that make you feel?
Yeah, it's you know, it's an optimistic feeling. I think there's a lot of there's a lot of potential to kind of, I think, optimize how we as a society engage with um interact with like the environment, and my family has a lot of engineers in it, and so I often can kind of say, like, there's usually an engineering solution to most any environmental problem. um so like you can think of I mean, I kind of mentioned hydropower earlier. I mean, it's like, okay, yes, we need power, obviously, as a society. It's got to be produced from the company's perspective. They've got to make some profit on it. They have maintain their operations, but can we you can implement certain spillway designs that mitigate like certain passage. There can be fishways. There can be you can pulse water, say, for instance, to improve like base flows for like spawning habitat or spawning times. So like if so there's there's usually middle ground options that are available. There can and then again with the and so for and there obviously are barriers that we need, but for those that we don't, that are clearly obsolete, we have a huge opportunity to restore those environments back to kind of maybe a semblance of kind of their historic greatness.
More native, more natural.
There's actually, I was gonna look at I mean, there is, I gotta bring up my find my quick. So there's like just in the United States there's over 90,000 dams, right? So, and again, I don't think there's an unrealistic expectation that we're gonna turn back the clock to 1610, and
no, we don't want to do that either,
like,
right?
if if we can restore many sites, then that will really move kind of the environmental and ecological restoration initiatives further, and and improve the well-being of local communities, and open up recreational opportunities, and improve kind of the quality of life issues in some of these sites that would otherwise be as like kind of statically arrested, absent some of these restoration efforts.
Perfect. Well, Jeremy, thank you so much for your time today, for joining me on Stories Sustain Us, and thank you for sharing the great work that you're doing that's getting some spectacular results of restoring those ecosystems there in the state of New York, and thank you for sharing your vision for a better future. So it's one that I share with you, and hopefully we can all walk together towards that vision. So with that, I'll encourage folks to check out the website to get more information about the work that you're doing as well, and follow your call to action to get involved in their local communities as well. So anything else you give you the last word, and otherwise I want to thank you for being here. Thank you for being a guest on Stories Sustain Us.
Yeah, thank you, for the opportunity. It was enjoyable to kind of provide my context to folks and let them know what what we're doing here in New York to improve kind of the river and riverscapes within New York. So thank you, and folks can go to the New York State Water Resource Institute website. I do barrier removal, but I have colleagues that we do things like culvert resizing, water infrastructure, invasive species management, improved drinking water, kind of lead pipe removal type stuff for communities. So, happy to, again, thank you, and happy to follow up too if anybody has questions with the work that we do.
Perfect. All right, Jeremy. Well, I wish you all the best and look forward to seeing future reports of all the great work you're doing. We'll stay in touch. Take care. What an insightful conversation with Jeremy Dietrich. Today we learned how Jeremy's childhood experiences, immersed in nature, set him on a path toward becoming a leading aquatic ecologist. His work with the New York State Water Resources Institute is showing us that stream restoration, through small dam removals and strategic infrastructure upgrades, isn't just possible, it's powerful. We talked about how outdated dams and improperly installed culverts disrupt ecosystems, degrade water quality, and prevent fish and other aquatic organisms from reaching the habitats they need to survive. Jerry reminded us that nature wants to recover. And when we take steps to restore natural flows, remove barriers, and reconnect fragmented streams, we're not just helping fish, we're improving water quality, reducing flood risks, and creating healthier environments for all kinds of species, from birds to bugs to people. What struck me the most was how Jeremy's work proves that big ecological wins don't always require big headline-grabbing projects. While the massive Klamath River Dam removals, for example, are historic and critically important, Jeremy showed us that even small dam removals, right in our own communities, can yield measurable, meaningful results. And that's encouraging to me, and I hope it is to you too. Look, we humans, we helped reshape these river systems over the last couple of centuries, often with very little understanding of what the ecological consequences would be. But now, with greater knowledge and growing public awareness, we have the opportunity and the responsibility to reshape them again, this time in partnership with nature. If Jeremy's story inspired you like it did for me, here are a few things you can do. Learn more about dams and culverts in your own community. Are there obsolete structures that might be candidates for removal or upgrade? Get involved with a local watershed group or nonprofit focused on stream restoration. Support policies that prioritize ecological resilience and fund nature-based infrastructure. And most importantly, talk about these issues. Raise awareness. Invite others to see what's possible when we give nature a chance to heal. You can also support Stories Sustain Us if you're so inclined, which I would appreciate, by subscribing on your favorite podcast platform, leaving a review, or sharing this episode with friends, colleagues, or that one neighbor who just loves fly fishing. You can also visit storiessustainus.com to listen, watch, and learn more about our guests and their work. And I hope you'll join me again for our next episode, coming out on June 24th, when I'll be speaking with the inspiring educator and author behind the National Park Classroom, a book and teacher program packed with strategies, resources, and ideas for bringing America's best idea, our national park system, into classrooms across the country. You're not going to want to miss it. Catch the next episode of Stories Sustain Us on June 24th at storiessustainus.com, wherever you listen to podcasts, and on YouTube. Thanks so much, as always, for being here today. Keep learning, and keep doing your part to make the world a better place. Till next time, I'm Stephen Shower. Please take care of yourself and each other. Take care.